All right, so let's talk about another type of function that you're going to have to deal with this year, and this is actually going to be what's called a piecewise function. So I want to make a piecewise function up and kind of just walk through it. So we're going to have a function f of x equals, and let's break this function into different pieces. That's where the name piecewise function comes from. Let's say we have part of the graph is 3x plus 1 if x is greater than or equal to 0. And then let's say it is x squared if x is less than 0. So there we go. Nice little piecewise function. So a piecewise function basically means that we have a graph, that we have a function that is piecemeal together. It's just kind of put together. It's not this pretty flowing graph that you're used to seeing in Algebra 1 and Algebra 2. All right, so let's look and see maybe how to graph this and then maybe how to evaluate a function. So let's look how to graph this. So everything will be based around 0. So I've got x squared is less than or equal to 0. So let's just start on the top. 3x plus 1 when x is greater than or equal to 0. Okay, so to find my y value, I just plug in my 0, and I've got 1 right here. That's going to be an open hole. That is not a good open hole. And then we have a positive slope, so it's rising. So this is the first leg. This is the 3x plus 1. The 3x plus 1. And it's an open hole. Oh, this is a closed hole because of the equal to. So that's filled in. Now, let's do the second part. My x squared. Well, x squared starts at the origin right here, because if I put 0 in here, I got 0, 0. And that is less than 0, so that's going to look something like this. And that is the graph. This is x squared. So this is the graph of this piecewise function. Not a pretty function that you're used to seeing. You actually have what's called a jump continuity. Jump discontinuity here, because from this point, then you're going to jump to this one and go off in the other direction. So let's look to see how to evaluate this. Let's say I want to do f of, let's say, -7. Well, I have two scenarios here. We have one case, two cases. You could have multiple cases. I've seen piecewises up to 15, 20 different cases. The most I'm going to give you is 3 different cases. So I'm going to look. All right, my x is -7. So I'm going to come over here and look. If x is greater than or equal to 0, was -7 greater than or equal to 0? No. So I'll go to the next one. If x is less than 0, so is -7 less than 0? Yes. So I'm going to use this part of the piecewise function. So what I want to do is I want to take the -7, I want to plug it in the bottom part. So I do -7 squared, which gives me 49. So if I do f of 0, I'm going to come over and look. If 0 is greater than or equal to 0, that's true. So I'm going to use the top part. I wouldn't use the bottom part because if x, or if 0 is less than 0, well, 0 is not less than 0, it's equal to. So we have to use the equal to part. So we're going to use the top part of the piecewise function to evaluate. So we're going to do 3 times 0 plus 1, which just gives me 1. So not terribly bad to evaluate. It's still just an Algebra 1 skill, but you have to look at what's called the constraint right here to figure out which part of the piecewise function you're using. And to graph them, you're just going to use this part for your domain, restrict it. You have to pay attention to the equal sign to fill in the dots, and then just graph the individual functions, the individual parts of the piecewise function.